fake news and lack of trust in our current world is a problem that goes way beyond the IT industry. It's a huge problem for our society and our civilization, I'd argue. And part of that problem is that digital data is just too easy to copy and fabricate with just, in the old days of paper ledgers. Sure, you could sort of like try and erase something, but you'd leave a trace, right?
Welcome to Hedera Hashgraph's Gossip About Gossip. If you are a developer, an entrepreneur, crypto enthusiast, or just trying to learn more about how distributed ledger technology and Hedera Hashgraph will impact your industry, then you'll love the episodes that we have coming up. Bookmark us, add us to your podcast app, and stay tuned.
Hey there, and welcome to Gossip About Gossip from Hedera Hashgraph. I'm Paul Madsen. I'm joined by Cooper Kunz. How are you, Cooper?
I'm doing well, Paul. How are you?
Very good. A friend of mine had listened to some episodes, and he reported to me that whenever you're on, I sound younger. So thank you.
That's an interesting bit of feedback there. It's reverse fountain of youth, per se.
Yeah, he didn't say I sounded smarter, but younger. We're not here to talk about my fading youth. We're here to talk about data, and data can be more trusted. Happy to welcome Guy Harrison from ProvenDB. Welcome, Guy. How are you?
Hi, Paul. I'm well. Hi, Cooper. Great to be here. Thanks for having me.
All the way from Melbourne.
Yep, and that's Melbourne, Australia, not Melbourne, Florida. Although I'm sure my accent gives that away.
That would have been a trust clue. Yes. So, Guy, you've recently announced an integration between ProvenDB and Hedera, and we're here to talk about that. So maybe before we get into that, what's your story?
I've been working in the database industry for an embarrassingly long time. I got involved in databases in the early 80s, about the time that Oracle was first starting to make its mark, and I worked as a developer, a database administrator. Got reasonably well known in the database area. I've written 5 or 6 books, depending on how you count them, on the topic. Been around the conferences, worked with MySQL, Sybase, MongoDB quite a lot. And one of the things that always kind of like vaguely disturbed me about databases is how inherently untrustworthy they are. As a DBA, I was just so aware that really I could make the database say whatever I wanted it to say. It might say that this accounting entry was made on a certain date, but I could just go and change that date whenever I wanted to, or remove the whole entry. And really what the database was, it was the basis for these big enterprise applications, that I had this total ability to manipulate it. And it always made me feel a bit uneasy, and I wondered, how much unknown manipulation we had. So when blockchain started rearing its, not ugly head around about 10 years ago, I really started to pay attention to how this new technology provided us for the first time a way of writing data and being unable to redact it. At least having, there's a limit to what you can write to a blockchain, of course, but at least, once written, it's written forever. And this goes for, not all distributed ledgers have this feature, but, the traditional blockchains, Bitcoin and Ethereum do. And of course, Hashgraph has that as well. So I was, and still am, working for an incubation lab attached to a Californian VC firm. We got very interested in the idea of sort of trying to bring the two worlds together, because although distributed ledgers had this fantastic feature of immutability, they just didn't have anything else that a database would normally provide: the throughput, the schemas, the query languages, everything that a developer would want to develop a really productive application wasn't there. So that was the genesis of the idea. And out of that came ProvenDB, which is a MongoDB compatible database service where everything in it is backed up by, anchored, if you like, to proofs on the blockchain. And I can talk about ProvenDB as much depth as you want to go, but I'll just leave it there for the moment.
Great. I think most people, when they cite their interest in blockchain, they cite the malicious behavior of others, but you were worried about your own bad behavior. So very commendable.
Well, yeah, kind of. Although, we've seen over time that insider threats are half of the story. In the most famous hacks of databases, it's not been so much DBAs, being bad, but attackers gaining access to their privilege. So in Carbonate, which is one of the biggest database hacks of all time, they just really sent out malware that took control of the DBA's computer, and from that point they were the DBAs. The DBA was being honest that the hackers had taken control of their privileges. So once you have those privileges in the network, you can give them to someone and you can vet them, but you can't be sure that those privileges don't sort of wander.
Yeah, that's fascinating. I think a lot of people who, use traditional applications, whether they're enterprise, consumer focused, really don't understand how easy it is to, whether maliciously or not, actually change the content that's going on in those, different types of systems, no matter what they're really built out of. Could you tell us a little bit, more high level, like what is ProvenDB? You mentioned some of the goals, but what is your really focus and ambition for the project?
Primarily, our primary platform is a MongoDB compatible database platform. In fact, at the back end, it is MongoDB storing the data. And we want to build a platform that people can build trustworthy applications on. And that might be in finance and accounting, legal document management, government, regulatory. There's a zillion cases, as you guys would well know, where we really do want to have a more trustworthy world. And I know I'm preaching to the choir here, but the whole issue of lack of trust, or not the whole issue, but fake news and lack of trust in our current world is a problem that goes way beyond the IT industry. It's a huge problem for our society and our civilization, I'd argue. And part of that problem is that digital data is just too easy to copy and fabricate with just, in the old days of paper ledgers. Sure, you could sort of like try and erase something, but you'd leave a trace, right? Like it'd be hard to take a paper record and completely fabricate it. And if you took an old one and completely replaced it, it would look new and so forth and so on. But so we created this sort of problem and we wanted to solve it. And there's a sort of a fairly wide range of verticals that we're hoping people will build applications on using ProvenDB. And we've had hundreds of developers starting to use it in the early adopter program. But where we're sort of focusing very directly is in regulatory compliance. So for finance and other regulated industries where they've got government legislation requires them to be able to show auditable, traceable transparency of alterations. That area we offer not just the database service, but we've got a prepackaged application that builds on top of it called Compliance Vault. And you can drag and drop or upload, or generally, you don't need to do any programming. You can just store your documents in here. And the document's provenance, that is to say when they were created and who they were created by, and all of the history of changes are sort of in that database. And each of those changes is anchored to a proof on a blockchain or DLT such as Hedera or Ethereum or Bitcoin even. And then the other sort of vertical that we're pushing hard towards is kind of hyper-secure databases for defense and finance, where you just really want a database where you need to be absolutely sure that it can't be broken into. And to that end, we offer it packaged with encryption at rest and in transit and all those other good things, as well as the tamper-proof provided by the DLT. But I'd come back to say, primarily, like you guys, we see ourselves as a platform for others to build on. So we're looking for partners and developers and so forth.
You indicated anchoring to a DLT. How does that manifest? What are you storing on the DLT?
Well, we're storing essentially the root of a Merkle tree type structure. So a lot of your listeners will be familiar with Merkle trees probably, but I'll recap for those that perhaps aren't. So what happens in our system, or one of the reasons why people can't just use DLTs generally, at least the older ones, to do this sort of stuff, is they're just too slow, right? Now, Hedera is very fast, but Ethereum and Bitcoin are relatively, orders of magnitude slower. So if you try and write something to them, it'll take sort of like 5 to 10 minutes in some cases for that anchoring to complete. And it costs, in the case of Bitcoin, $5 a transaction. So you can't sort of take millions of documents and sort of put each one of them on the chain, even if you had the room on the chain to do it. So we create a structure. It's a Merkle tree of types. It's a bit more advanced than that, but essentially a Merkle tree is you hash every document, every item that you want to anchor, and then you hash the hashes, and you hash the hashes, and you keep doing that until you've got one hash left. And that hash can actually prove any of the individual hashes in the tree. If you know the sequence of hashes between the root hash and the leaf hash, that's sufficient to prove that this document was part of this root hash. And so in this way, what we write to the DLT is actually proof of potentially millions of documents or database entries. And we've done a lot of work on Merkle trees. We have a structure called a tri tree, which is used in Ethereum. It's For those who are sort of technically oriented, it's a type of patricia tree. And that allows us to do even smarter things like prove the root of a directory all at once, to prove the data versus the metadata, and even to go inside the document and say, you had a complex JSON document. Well, this document is mostly correct, but someone's changed clause 3. And so you can sort of like get all the way down there and say, like there's been tampering and I can tell you where the tampering is. So it's a very powerful concept, and it really allows us to just use just enough DLT for our purposes versus trying to put everything on the chain. This is how we get around the fact that generally the overhead of blockchains is sort of preventing them from being widely adopted for these purposes.
And I love the premise of just enough DLT, right? It acknowledges, or at least our model would be that we don't want to significantly cause you to overhaul your processes. We just want you to call out to us as appropriate and necessary, just enough.
In my world of databases, there's this constant, you hear it all the time, should I use a blockchain or a database? And everyone always says you should use a database. And if you can ask that question, then to try and migrate off a database to a blockchain is doomed to failure, or pretty dangerous. But so we wanted to sort of like add blockchain to database rather than sort of like replace database with blockchain.
Yeah, and I like in your architecture and what you just spoke about, not only the fact that you're proving the contents of your MongoDB database, or potentially others, or whatever type of data store you're using, but also the ability to prove changes to that historical chain, who changed what when, and also be able to identify specific instances of tampering. That seems like a very valuable ability that most people wouldn't think as a complementary feature, a way that a blockchain could help out their database administration. So that's really fascinating.
Yes, it does. It does require that we store a lot more data than a normal database would. So we basically have to keep the old versions of data, and it's not without overhead. And I wouldn't say that you want to go to that level of detail for every application, but we can. And forensics is an important part of cybersecurity, sort of knowing what happened. And databases have had audit logs for a long time, but they typically contain very little information. Let's say such and such person issued an update statement against the table and change what to what. Often that data is gone or can be tampered with itself, which is the weakness. We built this sort of our infrastructure up on technology that is very easy to change, going right down to magnetic disk and solid state disk that can just be changed without sort of leaving any trace. And we built layer and layer and layer and layer on top of it. And until recently, we've had no choice. But now we do have an additional element that we can add that gives us a higher level of protection against malicious change.
Yeah, Guy, you mentioned Ethereum and now Hedera. I imagine when you look at a DLT, you think about the most efficient way to anchor. Use what the DLT gives you and optimize accordingly. So how are you using Hedera? How are you anchoring to Hedera?
It's mostly in the same way. We're using the consensus service that you guys introduced relatively recently. We could have done an integration without the consensus service, but the consensus service had a very, very straightforward API for us. So the integration was remarkably easy just from an API point of view, rather than having to do sort of specific sort of transactions into the DLT. We are relatively agnostic about the chain that we're using, in the sense that obviously we've abstracted as much as we can from the building up of the Merkle trees and all of the sort of database processing, and just the point at which we've got something that we want to anchor. So we didn't have to do very much engineering specific work for Hedera. But when we are looking at these chains, or these DLTs, and there are a lot, and we are sort of attracted to solutions that have two features. And one is, the faster the consensus can be achieved, the absolute better. And we started with Bitcoin because Bitcoin's, the obvious elephant in the room, clearly has the most hashing power around it, has been a honeypot for so long that if there was any way to break the Bitcoin chain, someone would have done it by now. There may be some future technology that allows it to be done, but as far as we can work out with current technology, it just can't be done, because otherwise someone would have done it to get hundreds of millions of dollars of reward. But it's so achingly slow. The idea that, a transaction to a database doesn't fully complete for sort of like up to 10 minutes. You can sort of like wave your arms, but during a demo, it's just a bit sad. You've got to do that thing like they do in cooking shows. Here's a proof I prepared earlier, because my proof's still cooking in the oven. And Ethereum's a lot better than that, but you guys have done a fantastic job of getting very, very fast consensus. So from the point of view of being able to sort of get immediate response to an interactive application and to be able to sort of like show and understand exactly what's going on, it's fantastic to be able to confirm a proof within, in your case, you'll confirm it within seconds. We'll confirm it within about 30 seconds, given that we have some additional work that we do. That's one side of the equation. How efficient is it? How fast is it? And the other side is how trustworthy is it? As you know, with whether it's proof of work or proof of stake models, a lot of this depends on adoption as well as sort of architectural sophistication. We have a fairly skeptical eye when we're looking at, I wouldn't want to say new DLTs, but throughout the ecosystem, we're very conservative. We want to go with the ones that seem to have the best credibility, sufficient hashing power, or a model in which an outsider attack is protected against it. So we were satisfied that Hedera had that.
Yeah, that makes a lot of sense. I think I saw somewhere that you actually anchored almost 500,000 records to Hedera in just about 2 minutes. Is that accurate?
Yeah, that was a bit of a shock to me, actually, because the anchoring of millions of records in one transaction is just something we've had for a long time. But to have it sort of confirmed so quickly, and to be fair, the vast majority of that time was just me hashing the data to be anchored. The actual Hedera confirmation, as you know, comes back amazingly quickly. We want to give our customers choices for the level of, I guess, convenience versus surety they have. And for some people, I'm sure the sheer sort of like historical record of Bitcoin adds a sort of a level of confidence that it's harder for a new technology to have. I mean, you guys must have hit this a lot of times. You're trying to explain to someone why your technology does what it does, but unless they're a cryptographer, there's some level of stuff they have to take on trust, right? They're not going to examine all your, not every one of your customers can examine all your code and sort of vet it and understand it and know why it works. So for some conservative customers, they wouldn't know one DLT from another, but they have heard of Bitcoin, and so they can choose that. But and there's also like how sure do I need to be? If I'm anchoring, if I'm a very big bank or something and I'm trying to anchor millions of dollars worth of assets, perhaps it's worth waiting 10 minutes to do that. But I might just be anchoring, I don't know, intellectual property that's of far lesser value, a piece of artwork I've done. And for that, the idea that I'd want to wait 10 minutes to get it on Bitcoin just seems like ridiculous. I might as well anchor it quickly to a totally trustworthy chain, but I don't have to go through sort of like a security officer or anything to sort of like explain what I'm doing. And so we're trying to give them the choice, and Hedera is a great way for us to offer a fully secure chain that's got great credentials, is very fast, and then we still have on offer the other sort of like kind of, I guess, better known chains that have at least a high degree of perceived security.
We acknowledge that, and that's totally fair, right? We're happy to be that option, and confident that over time we'll get the same sort of name recognition that will allow us to rise.
Yeah, so I think, this is the way I like to think about it. We're in the state of the industry similar to where fingerprinting and DNA was at the very early days of those technologies being around. And in those, with DNA proofs in the first court cases that relied upon them, they had to get geneticists in, and there'd be big charts showing chromosomes, and the jurors would have to be explained, what is a gene, and, what is a genetic fingerprint, and how did I get it, and all that sort of stuff. And then we just progressed as the technology became more ubiquitous. We just projected to the point where people understand what DNA proofs are, and they just accept them, and you just need a lab technician to come and say, I sequenced this gene, here it is. We're still in the stage where you have to have those long, awkward conversations to try and explain how your technology works. So that's just a fact of the early stage of our industry. As it gets more mature, and as you guys have been, once you guys have been sort of like around for a number of more years, it will just be taken for granted that, if I write something to Hedera DLT, we know for certain that that entry to not be modified.
I really like that analogy of, gene sequencing, fingerprinting, and how those types of physical proofs are very analogous to these digital proofs that you are anchoring and allowing developers to use in their databases. So that's super fascinating there.
Except, Cooper, do DNA sequencing labs, do different labs differ in their latency and throughput? I mean, how do we tease our value out?
I'm sure some of them do differ in the quality of sequencing and how long that it takes and how trustworthy some of them may be. Maybe some of them have some unknown attack vectors that we haven't really identified yet.
Well, it's certainly true that DNA sequencing has gotten a lot faster in my lifetime. I did genetics at college, and the process of getting a sort of like a basic gene sequence was, like weeks at least to sort of get something that you could look at. Now there's machines that just do it, within seconds and minutes. It's all the latency now is in sort of getting the sample to the lab and getting it in the queue to the technology, right? We've sort of eliminated everything else. So, if you wanted to sort of think about, I know this is how your founders thought about Hashgraph as a sort of a next generation technology. So just as people brought out new types of gene sequences, the proof of work algorithm was a complete breakthrough, and Bitcoin, like I'm sure we all acknowledge what a fantastic combination of economic theory, game theory, and cryptography it was. But I think everyone in the industry is also aware that proof of work at the scale of Bitcoin can't go on, right? It's, aside from anything else, it's just too harmful to the planet. And so we need to have this sort of capability, but built into technologies which are far more efficient, far less sort of greedy about energy consumption and more usable. And so we're again, we're on a journey of early days in the technology. You guys are the pioneers of new technologies. It doesn't mean that every pioneer will sort of succeed, but those pioneers are very important to taking it all to the next level.
Super interesting. And so you're building this ubiquitous technology on top of MongoDB, which is a really popular database. I'm curious how much more difficult it is to integrate with ProvenDB rather than a traditional MongoDB deployment. I assume you don't need any specialized cryptography background or knowledge. How much of this are you abstracting away from a regular DB admin?
Oh, pretty much all of it. So the database acts completely like a normal MongoDB database. It's not 100% compatible because we obviously have to do some things differently. Plenty of applications will just port onto it with no change whatsoever. And the proofs can be run by a scheduler, so you don't need any code changes. And we have customers who've done exactly that. And I think the point for our adoption is that for the database service, you'll either be using MongoDB or be prepared to use MongoDB. If you're not into MongoDB, we have an API that you can use to do the anchoring side of what I talked about directly against whatever your data might be. And that was actually that API I used when I was anchoring those millions of records against Hedera. And so that API just can hash anything, create the advanced Merkle trees I talked about and anchor it so you can sort of get your data from Oracle or Kafka or wherever your data might lie. We offer a lot more in the database, a completely compatible database layer, query languages, all that sort of stuff. But we didn't want to sort of restrict ourselves just to that area of the market.
Guy, you mentioned Compliance Vault. Can you, and how it would, I guess, abstract away from your customers the specifics of a DLT? How does that work?
Well, Compliance Vault is an application built on top of ProvenDB, similar to an application that a partner or a developer might write. And it is a relatively straightforward document management system. So you drag your documents in, or you upload them using a command line, or you email them to the system, and then automatically it stores them in the database. It serializes them and all sorts of stuff, and then it creates a proof for all the documents. It keeps all the versions of the documents. It's got a document previewer where it's kind of relatively basic in terms of its functionality, but we're going to bring in things like OCR and metadata recognition. So you can put in a sort of a scan of a document. We'll OCR the data in there, and the proof can contain even potentially proof of the actual text. And again, when we're talking about, what changed and what didn't, we might be able to get sort of very fine-grained about that. But it's not, seeing is believing. It's very easy to sort of like show you. We're on radio essentially, of course, so, I can't. But you would just sort of like take your, board minutes or your will, perhaps some intellectual property you were working on, and you just drag and drop it into the vault. And then at any point in the future, we immediately give you a certificate that you can use to show the blockchain proof. You can export it out of the vault into a sort of an envelope that contains the proof and the data, and you can validate that separately. So it's a very easy to use solution for proving digital assets, personal or small business digital assets, or large financial systems would all be able to use this to very quickly, within minutes, ensure that they have proof of the provenance and integrity of digital documents.
Guy, you cited at the start your long history in databases. I think it was a friend and colleague of yours for many of those years, Christian Hasker, that our colleague at Hedera, that recommended we talk to you. But Cooper and I wanted to do it anyways without Christian's endorsement. And this was great. Thank you very much, Guy. Fascinating to hear what ProvenDB is building on Hedera.
Great. Thanks a lot, guys. Really nice to talk to you.
Thank you for listening to Hedera Hashgraph's Gossip About Gossip. If you liked the episode, please subscribe, rate and review, and also share and tell your friends.
Or connect with us on social media like Twitter, Instagram, etc. at Hashgraph, particularly if you want to leave us feedback on the podcast. We look forward to hearing from you.